Start recording. Welcome to Wickerson Studios. Everything's good. I think we are ready to go live. I am recording. Perfect. I'm going to grab this and just do a quick advertisement over here on LinkedIn, assuming it's in good shape. This will just take a couple of seconds to set up because my internet's been on and off on a Sunday out here in the middle of Kansas. Typical. I think I just want to go to do a quick ad on LinkedIn. That should bring in a few people to watch. So this is it. I'm going to release my first live now. And this is Python app release party. All right, that's what we'll call it. And with that, show all activity. I might do a little plug. It's not really a party, but I'm sitting here on a Sunday with two of my youngest kids, and that's party enough for me. And we will grab that and put it out for contact in Facebook as well. So we don't need everything running, but it looks like everything's good. I can see myself. And we have a live stream. We have a couple of viewers, so that's great. So let's get started. This is the sixth and final script for NumPy Basics in Grasshopper, and it fits to over 4,000 lines of code in a Python app. And I ended with random walks and visualization for those random walks. And then I finished the whole thing, and the conclusion is, where should we go from now? And I put it a poll. The last two data visualizations I did were pretty basic. They were simply a single walker that I generated going through Grasshopper, which you can see here, and a multiple walker. And so the multiple walker basically tracks different paths, four actually, if you consider 4 rows. So it's the data visualization for a kind of predictive model. And so that's simply put what it is. This obviously will red out if I don't have anything to walk through. And there it is, you have the green internal. And so I have tried to do a lot of this work to begin with. Let me grab all these as data visualizations and put preview on, and then just select through what I actually want to highlight. The entire script 6 is here, and it basically covers input-output files, linear algebra, data visualization, and that. But let's go back to the first one. Now, it's hard for me to guess which is the first one here because my names are too long. These are all available now in one package at Wickerson Studios, which definitely needs to be restarted because my internet's been cooking on and off today. But WickersonStudios.com has everything. This is the complete bundle in NumPy, and that houses all 6 scripts, an introductory, and the Python app, which is over 4,000 lines of code. I've wrapped that all into one now. And then the shop itself, if you're not just interested in getting the Python app, you want to get the full package of all 40 bundles, including that, I have that at $9.99. Everything else ranges between $1.99 to $6.99, and I have a tutorial hour for $20 if people want direct help on this. But you have to just apply for what that is. So not trying to make this a whole sales pitch. I want to jump in here, take my Rhino screens down, and show you that each one of these is up and running. So let's just predict which one we did. There's 5, so I can only imagine this is 1. Nope, that's 2, and that would be 1 possibly, and there it is. The first script we went into at the very beginning of this document, this 4,000 lines of code, is I have written into a Flask middleware the first introductory scripts, which just help you get hops up and running. And they come with Rhino Compute. There's guides for that. I have tons of videos on this. And the videos you might want to check out for this is, if you don't know me, I've produced over 1,000 videos, and we're adding to that daily at Michael Wickerson on YouTube channel. I'm just going to pull that down here. And here you can choose from pretty much anything that get your that you become interested in. And I'm wondering if we're still live or if the internet just kicked off on me again. I think it's still good, but it's got some lag time, which is a pain in the butt. This is a pain if that's not working. Looks like there is some lag. Anyhow, I am recording this video. At least let me double check that I am. I am. And all of these playlists are in here, and everything goes back to 1,000 scripts. So that's all up for you to do. Have a look at, figure out which one you actually want. But to find out what you want to spend a little time on that, and then you'll walk through this entire script. And once we get down through the first part, you'll start with Python for data analysis. And the Python for data analysis starts with making 1D arrays. And that flows through with this section with some data visualization. It gets a little more complex as you go with data visualization, and you're going to jump over to more complex, doubling those, doing some array multiplication addition. Now these will be element wise. They won't be like matrix multiplication, which we'll get into in the last sections. But this is one thing to start. I'm a little upset that my internet just is terrible. I'm going to restart this stream and see if it's not on. It says I'm streaming, but we've got a problem with it. It's just, oh, maybe it's live again. Check, test. Nope, I think we're good. And it's at least been recording. So sorry for this, but I'm just having technical difficulties. Other data visualization, you're done. And then you can step into the next one, which is continuing along with the arrays. And we're going to go into NumPy Basics. Again, we're going to get into what arrays are about. Making shapes, finding the dimension of an array, the shapes of an array, the zeros, the ones array, making a nice A-range array, with different shapes and outputting those. And the one thing I'm doing is I'm solving the tree problem that happens with array lists to trees not working in Grasshopper. And that's been fairly successful. So that's here for people that want to dig into it. Then you've got zeros like array, empty like arrays, and additional things. And we keep going, making data visualization to using the IArray, the identity matrix, and then finding data types for three-dimensional array objects and actually converting those, casting or converting them over. So I have one example of that, of floats to an integer. And you can make this as advanced as you want, but as you plug through this, you'll see that there's more and more categories as we go, creating arrays. And then we're going to get into, in a minute, probably on the third part, because we're already 800 lines of code in here, arithmetic array objects. What you have is a call factor of how you'd call something when you come to one of these scripts. You may have to write it again. I just got a message from my wife over here on my phone, and my kids are, I think, talking to me from the other room, but I'm just going to try and deal with it. And you can see that we go through a lot of things with square root, exponents, the log based, and I think I do a couple of visualizations. This is a nice one that uses math to generate an interesting geometry. Blue is where I do have a data visualization, and then I get into some comparison functions and some logical functions. Keep in mind, this is happening with arrays in vectorized computation, then being put into Grasshopper for data visualizations. What you're bypassing is the need to, let's see if we can pull up 3. No, that's 4. I figured I'd pull it out of order. Let's see if this is 3. There it is. And there's a 3. There's a video group for 3A and 3B, but it all comes out of here. Now you're going to go in and see hard-coded and parametric problem solving, which I'll edit down, but you'll have examples in here of call functions that are either hard-coded and parametric, and then we're going to show all the possible things of working with all types of wonderful array functions. So they're all here, and we're going to get into slicing and indexing, which actually becomes absolutely incredible, and that's where 3B starts, and you'll see some data visualizations in the Rhino that solve that indexing. This is incredibly organized. Over here is where I'm using the old for loops, and then I fixed them up over here for slicing and indexing 1, 2, and 3-dimensional arrays, and output them as trees and give you some crazy power when it comes to actually doing what you've always wanted to do to a list of lists of lists, which is get total control. So data trees and all those fancy tools over here in stats of trees, really, you don't have to get into all of these masks and these relevant items and path mappers. You can control it all from the numerical start in NumPy. Absolutely powerful. And then I'm going to finish up with Boolean indexing on ND arrays, fancy indexing, transposing a matrix, matrix multiplication, and swapping axes. And then you can jump over to, I believe, 4, which is here. And what's happening in this one, another huge script, but it's actually fairly straightforward and simple. And I left a few for you to do, even though I wrote those down here as we get into indexing. And then we get into, where do we go after that? I think we go all into randomness. And I thought I had a category for randomness here. Let me see if I go. Yeah, random number generation. So that's what this page is all about. So you're all the way over in the Grasshopper 4, and you're going to realize you can do anything from random modules to seed modules. and permutations, shuffles, uniforms, and I'm using a basic 4 by whatever length of column arrays to start. And that's one thing you have to notice with NumPy and the Grasshopper. You have to dictate how much data you want as outputs, just like for any outputs you're dictating from nodes over here. But the power of what I'm doing is you're really only using the one hops plugin to make every single function from it. I'm sure there's hundreds of functions by the time you look at all this, or at least well over 100 functions to what I've provided in this app. I left some, so the NumPy array beta I just left off. I did want to use the binomial one, and I wanted to use the chi-square to generate 2 visualizations. And once again, I should go here and make this kind of my favorite baby blue, which people know kind of trademarked from how I kind of do this. And that's it. You have to keep in mind that you have to deal with this array problem tree. To list to tree and use the entwine node. So that's a fairly straightforward one. And then let's go down to 5, and that's 6, the one I just finished up. Let's see if 5's here. There it is. This one, as we go, we'll get into universal functions. So let's go down here and see if I can pull up the universal functions, which are kind of useless. I mean, they're not useless, but they're 1D arrays, so they're just lists. So you could just do those binary and unary functions in Grasshopper to start. But there's a nice modification file here, which takes, I'm pretty sure there's a node in Grasshopper vanilla that will take your decimals and separate them from the integer values above it. And then array-oriented programming is where it starts to get good. And I'm going to make a mesh grid visualization. You can see it comes out looking pretty nasty for information that could be used in Matplot library. But from that, you could start to break that down, consider how many paths you want to make for these nodes, and make some simple visualizations based on mesh grids, but using the geometries within Grasshopper. So you're basically doing Matplot library on steroids, at least in my opinion. And I've got a very nice script here that generates kind of random chairness, and I thought that was kind of nice. So let me grab that one, pull it over here, slam it over here for a second. And I showed this in videos before, and I'm talking pretty fast, but let's just grab that little chair. And you've got a kind of solid object that I've done a little do-si-do in Grasshopper, but it's driven by this very simple, form that you can change the design of that from conditionals. So nice thing to start. The where conditional is absolutely fantastic for vectorized functions on arrays. It's absolutely like everything on speed. And then I've got mathematical operations that you might want to go into, and that'll break down at everything that you're looking at, axis arguments, and come sum, cumulative sum, which we used in that last random walkers. And then all of these I put to the test of standard deviation, argmax, variance, and things like that. And then where did I go in the end? Boolean arrays, and then things for sorting. And sorting can be kind of fun when you start thinking about what to do. And then I have this unique and other set logic as we go through and start thinking about what we want to do. So I think I did all of those when I was done and have them coded in, and you can just bring in the last ones if you want to do that. Then the last one I think was 6, which is what I ended with. And so this is a ton of this is a ton of work for $5.99, but I would say just grab my whole bundle, 5 years of work. I'm disseminating it at pretty much like the minimal amount I could possibly do to serve for parity all over the world to get people to do this. And I'm tracking what's of interest. Please go back to LinkedIn. Let me know if you want me to move on to advanced NumPy operations, which is getting started with pandas. That'll be my next decision. And what it's nice about this script, when we get down to the end, let's pull it down to the end, you'll see that what we have a choice to do here, right in the last section, is we can start to consider where we need to go now. And I should make this a lot bigger. Pandas, SciPy, scikit-learn, stats models, and many others. So that's really key as to where we're going to go when this is done. All right. I might do a demonstration of this last visualization in here, which I kind of liked. It's just a very simple model for a random walker. And how did I break that down and build it? Because it's just numbers. It's basically a prediction model for like flipping a coin, but flipping a coin isn't very graphic. So what I thought I'd do is here, kind of, maybe it's probably best to just watch it on the front. And you have 2 models. You have this one, which is the green model, which just does a random walker. And you'll see what I kind of did. It's kind of do-si-doing and dancing out and deciding to go right or to the left. But of course, if it goes to the right and the left and doesn't lift or bottom out on the Z or add components, I've just swung it with a circle population and deconstructed its points to rebuild the points with that data to interpolate it and put it into a subdivision, and then colored it that green. And I do have a little plane here that I like, so I can kind of divide it for top and bottom. And I'm building some really cool geometries with stable diffusion from that with Hugging Face. The other one I have is, let's take this one down so we don't need to look at it, is that the power of NumPy is that you can use multiple arrays. You don't have to do a random walker for one. We could have a random walker 4 that are racing to get out. And you can see that red beat it in this direction and kind of held the lead all the way through. If you wanted to make a game of it or a visualization for it. So basically it's, probabilities, numbers coming out, but doing a little data visualization on top of it. That, in a nutshell, is my Manic approach. I also want to just give a little plug. If you're interested in it, all my past work, which is listed here, basics, intermediate, and advanced, the complete bundle for NumPy, which I just finished, is $5.99. It's everything you need to get all of this up and running. You'll see that when you click on it. And then the master package, the full bundle, has absolutely everything. So let me click on here. I hope we still have internet going. There we go. And you can add it to cart. And I'm going to go over to a thing called, because PayHip's okay, but you got to set up an account. So I think what I'm going to do is go over to Stripe, I think it's called, or something like that. Try that this afternoon so you don't have to make an account. But thanks for all your support on here. I'm going to shut off my recording